The word lenticular means shaped like a lentil, and this also applies in the context of lenticular imagery. Lenticular imagery works using lenses named after their lentil-like double convex form. It can be used to simulate 3D depth in a 2D image, give the impression of movement, or even transform one 2D object into another. But at its core, lenticular imagery is just a way of showing you different 2D images depending on which angle you look at it, much like how video is a way of showing you different 2D images depending on what time you look at it. This is usually done by interlacing two or more images, which means taking these 2D images and splitting them into slimline vertical columns, then alternating them into a single 2D image together. Then you apply a thin lenticular lens on top, which refracts the light in a certain way, which only shows you one of the images located beneath it depending on which angle you're looking at it. As a result, this can work with any 2D image providing that the lens is lined up correctly. So this camera with two lenses on the front takes two different images from slightly different perspectives and can then show a 3D effect image on the back using its lenticular display. However, this isn't just limited to the 2D world. It is possible to 3D print a lenticular style image, and in this video I'll show you how you can take two 2D images and convert them into a 3D printable lenticular style model. So let's have a look. This process uses a piece of software called Luban3D, not to be confused with Luban by Snapmaker, and can be found at luban3d.com. It's available for Windows, Mac and Linux, and you can use it for free with limited functionality and export quality, or get full access either with a 30-day free trial or one of the paid licenses. Download it via one of the links on the website and let's get stuck in. Before you get started, you'll want to make sure that both of your images that you're using are saved in the same folder on your computer. You'll want to make sure that they're both the same aspect ratio to make sure that one isn't cropped, and ideally the same resolution. Once you've done that, it's time to launch Luban. Now, you'll instantly notice that Luban doesn't have a fancy, flashy user interface, but it does have a fantastic set of tools which I'll be covering across a number of videos over the coming weeks, so make sure you subscribe so you don't miss them. Don't let the retro aesthetic put you off, it's worth it, and when you know where to look for what you want to do, it's super easy to use. To get started, go to File, then go to Create, and then select Photo Magic. This will load a list of new options, but these aren't the ones we want. Under Method at the top left, select Lenticule. This will then load the mode that we want to run today. Next to Photo, choose Browse, then find and select both of your images before clicking Open. For this example, I'll be using this photo of myself sporting the 3D Revolution cap available at 3drevolutionstore.com and a stock photo of a Prusa Mark III printer. Immediately is created a lenticular style model with the two images that you selected. Let's see how this is looking before we adjust the settings. The navigation isn't always the smoothest in this user interface, but as we look more to one side of the model, an image really starts to come through, and when we move to the opposite side, our other image becomes visible. I know this image is quite blocky at the moment, but once we've adjusted the settings, we'll be able to get more quality out of it. If you wanted your images to be visible on the opposite sides, the order that they're placed in appears to be based on the creation date of the file, frustratingly not based on the name, for example, having 01 being the first and 02 being the second. So if you open one of the images in a photo editor and save it as a new file, or if you've downloaded it before, just download it again, that will then have the most recent creation date and then should be the leftmost facing image. Now let's work our way through what each of these settings does. The first option kind of shows you a couple of different things. Switching between bright and dark mode will change the colour of the 3D model and the colour of the background. Bright mode features a light grey model and black background, whilst dark mode features a blue model and a white background. This can be used to both see how it will look with lighter or darker material, but also how it will look when front illuminated or rear illuminated. Bright mode represents how it will look printed in a lighter colour filament and illuminated from the front with a darker backdrop. Dark mode represents how it will look printed in a darker filament and illuminated from behind. More importantly, these modes also adjust how the shape is formed. With bright mode, the gaps are used to represent the darker parts of the image and the model itself represents the lighter parts. Dark mode leaves gaps where there is a lighter part of the model and tries to fill in the darker areas with the model. The other thing that's important to note here is that bright mode allows there to be shadows, which will add significant detail under the right lighting conditions, whereas dark mode doesn't allow for shadows, so will present more of a block edge image focusing more on negative space. As a rule of thumb, I generally find that bright mode is best when you're working with photos, and dark mode is best for text and graphics. Due to the level of detail in these images, I'm going to leave this in bright mode. The next two options, model size X and model size Y, are just to set the size that you want the model to be in millimeters. The larger it is, the more detail it's capable of showing. It's set to maintain the aspect ratio of the dominant image that you selected, so when you change one of these it will change the other automatically to maintain that same aspect ratio. With each of the text settings here, you'll need to hit enter on your keyboard for it to take effect. Just clicking away or into another box won't cause it to take any action. Next up is thickness. The thickness affects both the thickness of the model itself from front to back, which will then translate as the height or z-axis when it's being printed, but also affects the thickness of each of these vertical bars. As a result, the smaller the thickness, the higher the level of detail that the image can show. You want these vertical bars to be small enough to show suitable detail, but thick enough that your nozzle can print them efficiently. As I'm printing with a 0.2mm nozzle, I'll set the thickness to 1mm, but even with a 0.4mm nozzle, you should be fine printing at 1.2mm or more without much loss of quality. After that we have border size, which is, as it sounds, the size of the borders around the lenticular image. I'd suggest making this a good size so that you've got something solid to hold on to when viewing it, and especially if you set a thin value for thickness, you want a strong border to hold it all together. Speaking of strength, the next setting is reinforcement bar. As I mentioned earlier, the image is produced using these vertical bars, and these horizontal bars are just here to add strength and reinforcement. As these vertical bars can be so thin, a slight bit of warping or bending due to pressure or strain can ruin the image, so the reinforcement bars can help hold it all in place. You can adjust how many reinforcement bars you'd like to include here. Obviously, aesthetically speaking, the fewer the better. Also, the shorter the image, and therefore the shorter the vertical bars, the fewer you're likely to require, as they'll be less prone to bending and breaking. I think 2 is probably a safe number for this one. Finally, we have resolution, and for that I'll zoom right in. These printable lenticular images work by creating variations in the shape of each of these vertical bars, so they stick out more on one side in certain areas and less in others. As a result, you can see through different parts of the model when viewed through different sides, and through negative space as well as shape and shadow, the images are created. Technically, because it isn't using a lens to refract light, this isn't strictly speaking a lenticular image, but the result is near identical and it's the best way to easily describe what is being produced. The resolution setting affects the number of variations in the vertical bar, so if we set this to 5, you can see that there is only a few facets on each vertical bar between each reinforcement bar. As a result, there's only so much detail it can physically represent with this many variations. You may have noticed here that this also increases the size of the reinforcement bars. Effectively, the thickness denotes the horizontal resolution or the thickness of the vertical bars, whilst the resolution denotes the vertical resolution or level of variance in thickness of the vertical bars and the thickness of the horizontal bars in the y-axis. Don't worry if that last bit went a bit over your head, as it did mine as I was saying it. It was just an over-convoluted way of explaining what these settings do. If I set this to 1, you can see that the number of these facets increases dramatically, allowing it to vary the detail and brightness significantly more, therefore increasing the level of detail in the image. As this doesn't have a huge impact on print time, let's set this to 0.1, below which you generally can't notice any further improvement anyway. And that's all the settings. Below this you can see an estimated file size, and then we have a button to export our model, so let's hit that, Save Model. Luban doesn't give you the option to name your file on export, so just select the location that you want to save it, and it will then create a new folder and save it within that. Now let's get our slicer of choice opened up and we'll get our lenticular model imported. Once imported, I'd suggest using the Auto Orient button as it can be a little fiddly to see the correct side to print on. But if you want to do it manually, if you zoom in, you'll see that one side features the variations in the vertical bar thickness that creates the image. The other side has perfectly straight vertical bars. You want to print with the uniform thickness side, which is the side that you'll be viewing it from when complete, face down on the print bed with the wavy side facing up. Now, because the variations in topology and thickness does vary across the layers, printing in a thinner layer height will technically increase the image quality. However, the difference in quality between layer heights is so small that the increase in print time usually isn't worth it. So whilst I wouldn't suggest going with the thickest layer height that you can print, it likely isn't necessary to go for the thinnest your printer is capable of. That said, this will vary from image to image, and you may want to go with the thinner layer height for some images. There's not really any specific settings for this, so you can pretty much just run one of your settings defaults. So with that done, let's get this printed. I'm not sure what I was expecting, but I think that it came out really well. I'm not sure how well you can see that there, so I'll intercut with some tighter shots, but you can clearly see the Prusa Mark III and then myself wearing a 3D Revolution cap available at 3drevolutionstore.com. I'm impressed with the level of detail that came out of this. I was really expecting it to be much more of a block shape than a detailed shaded image. But what's also cool is because each image has its own set of faces, providing you set a suitable thickness in Luban for the size nozzle you're using, ideally which would allow for 4 or more lines per vertical bar, you can then paint your individual images different colours, therefore producing a multicolour lenticular print. I find it easiest to do this whilst viewing the side with the straight vertical bars, not the side with the wavy bars, so for now I'll orient it the other way up and slip into the paint tool. Use the fill tool and adjust the angle so it only paints the shaded areas, and once you've finished on one side, flip to the other side to see the other image and do the same again on that one with your colour of choice. After your first pass you may need to zoom in and go over some areas again to make sure you didn't miss any spots. When we slice it, you'll see that we still have a white layer on top, but as we go down through the layers, you can see that it's then divided into 2 rows of 2 lines of each colour. As I said earlier, if you're doing a multicolour lenticular print, you'll want to make sure that the thickness that you set in Luban allows your nozzle size to paint at least 4 lines per vertical bar, so that you can then get 2 lines of each colour on each side, therefore reducing colour bleed. Now flip it back over so these straight lines are on the print bed and you're done. Right, let's see how this one comes out. Well, I'd say that is game changing in how bold and clear these images are, compared to how when it was in a single colour, you could see the image but you had to look for it. There's no mistaking that. You can clearly see the 3D Benchy and the 3D Rev logo if you ignore my little painting mistake in the top left of the logo there. I'd say even if you were to paint both objects the same colour but have them different to their respective backgrounds, that makes such a difference in how these images look. These are great, but as I mentioned earlier, to get the best quality out of them, you need to print them particularly thin. Whilst this does mean that they're going to print fairly quickly and they're not going to use much material, it also means that you can't just then stand them on their end. I've created a range of simple display stands available for a variety of thickness and size lenticular images, so you can then display them freestanding. I'll leave a link in the video description. I hope you enjoyed this video. It was definitely a fun one to make. If you found it useful or interesting, please do hit that like button and hit the subscribe button if you'd like to see more from me in the future. Don't forget you can get early access to my videos, exclusive access to the 3D Rev Discord community, and a members discount at 3drevolutionstore.com, where you'll find 3D printing and maker themed clothing and accessories, and a load of other goodies by hitting the join button below my video and becoming a channel member. Thanks very much everyone, and until next time, happy printing. If you're one of my 3D revolutionaries, thank you so much for your support. If you're not, hit the join button right now and help me help you. For now, chuck on one of my other videos, learn something new or have some fun. Thanks very much everyone, and until next time, happy printing.